What is crypto? Cryptocurrency is often presented as a technological innovation, but at its core, it is a redesign of monetary authority. Blockchain is only the infrastructure. The real difference lies in who sets the rules and who controls supply. Different cryptocurrencies represent different models of monetary architecture, and those models are not the same. This video analyzes cryptocurrencies through three structural dimensions: governance, supply control, and access. Governance refers to who defines and updates the rules of the system. Supply control refers to who determines how new units of currency are created or issued. Access refers to who can participate in validating transactions and using the network. These dimensions vary across different models. For example, Bitcoin enforces rules through distributed consensus. Public crypto networks may coordinate upgrades through developer communities. Stablecoins are typically governed by issuing companies. CBDCs are administered by central banks. These are structural variations in how control is organized. Bitcoin is positioned closer to algorithmic governance. Stablecoins and central bank digital currencies are positioned closer to institutional governance. To illustrate these dimensions, we will use the Bitcoin model as a reference architecture, since it provides a clear example of decentralized cryptocurrency design. Blockchain is where governance and supply rules are technically enforced. Blockchain is a distributed ledger. It is the technical mechanism that maintains ledger integrity. It provides transaction recording, transparency, immutability, network validation. However, blockchain does not automatically define governance, supply control, or access rules. Different systems can use similar infrastructure while implementing very different control structures. If governance defines the rules, access is defined through control of private keys. In decentralized networks, private keys determine control over assets. A wallet does not store coins. It stores cryptographic credentials that authorize transactions. If a user controls the private key, they control the assets associated with it. This creates a direct relationship between cryptographic ownership and monetary authority. There is no automatic recovery mechanism embedded in decentralized systems like Bitcoin. Loss of keys results in permanent loss of access. Custodial services offer convenience by managing keys on behalf of users. However, this reintroduces institutional dependency. Cryptocurrency shifts control from account-based authorization to key-based authorization. Whoever holds the private key controls the funds. This leads to the fundamental rule of decentralized ownership, often summarized as, not your keys, not your coins. Because the private key is the only proof. Access is not only about keys, but also about how identity is treated within the system. Cryptocurrency systems operate on public ledgers. Every transaction is recorded and visible to anyone who chooses to inspect the blockchain. Transaction amounts, timestamps, and wallet addresses are transparent by design. However, wallet addresses are not inherently linked to real-world identities. An address represents a cryptographic identifier, not a name, passport, or personal profile. This creates pseudonymity, not anonymity. If an address becomes associated with an individual through exchange verification, public disclosure, or blockchain analysis, its entire transaction history can be examined. In networks like Bitcoin, transparency is structural. Privacy requires additional tools or behavioral precautions. In practice, governance, supply control, and access are combined in different ways. While the conceptual framework may be similar, real-world implementation varies significantly. Bitcoin emphasizes minimal change, fixed supply rules, and high resistance to governance intervention. Other public crypto networks may prioritize programmability, faster upgrades, or flexible monetary design. Stablecoins operate on public blockchains but rely on centralized issuers to maintain asset backing. Central bank digital currencies may use distributed technology while remaining fully controlled by monetary authorities. Technological infrastructure alone does not determine control. Monetary architecture is the structural result of how governance, supply, and access are organized. Digital monetary systems can be understood as variations in monetary architecture. Bitcoin represents a model with algorithmic issuance and distributed governance. Public crypto networks introduce programmability and varying governance structures. Stablecoins combine blockchain settlement with centralized asset backing and corporate governance. CBDCs represent state-issued digital currency, where monetary policy and governance remain fully institutional. These systems differ not only in technology, but also in control structures, policy flexibility, and authority over rule changes. These structural differences do not make one system inherently superior to another. They represent different trade-offs between decentralization, control, flexibility, and stability. Cryptocurrency is not a single uniform innovation. It is a structural redesign of how monetary systems can operate. Some models prioritize algorithmic predictability and distributed control. Others integrate digital infrastructure within existing institutional frameworks. Because governance and supply control can be structured in multiple ways, cryptocurrencies expand the design space of money. This structural flexibility enables programmable money, alternative trust models, and new forms of financial coordination. Understanding these structural differences is the first step to understanding where this technology is headed. Which model would you prefer for global adoption?